Hey everyone, welcome back to my YouTube channel. My last video I explained what an agent is, like what is an agentic system. Today I'm going to show you a practical example of what a agent actually is and how can we build our own agent. So I've seen a lot of videos that just talks about agent all, but no one actually shows how to actually build an agent. So that's why I thought like why not let's create a agent that can be used in a like let's say e-commerce store or somewhere else. The pattern is common. You can follow this pattern to build any agent. At the end, agent is nothing but a loop that is controlled by LLM and executed by our code. So LLM is not the one or not the one who will execute the things. It will tell you what to execute, how to execute, and where to execute. So with that being said, let me show you an example of what we are going to build today. So this is a e-commerce store agent which can do all of these things. You can just extend these to as many things as you want. So let me show you an example. Like let's say you just say, hey, so right now it's running on Gemini 3.5 Flash model. So it greets and then let's ask where is my order. It is asking me like if you have an order number or an email address. I have some orders in my database and that belongs to a customer. So let's say email ID of the customer is this, and he enters the ID. Then these are set of tool calls that it actually make. Right now it is calling the customer tool, getting the information, now getting the order details. The backend is built out on Supabase. All the tables and everything is in Supabase, and once everything is done, it gives us it gives the list of the orders with status and all. Like if you just want to ask, like let's say, hey, like let's ask for this, when is this order going to be delivered. Now it will again go and call some tools. So right now it's calling order details. The order for this currently in processing. It was created on this date. Our warehouse actively preparing, and orders are processed shipping 1 to 2 business days. So it does not have any delivery date information. That's why it is not able to give a delivery date. But if we extend it, and like right now it is even not practical for it to give a delivery date because it is not yet shipped right now. Let's say our agent do not have that context, and let's say if I ask for this product that is already delivered, when is my order going to be delivered. Now again it will call the tool for order details, and once it get the result it will just show us. So it says that hey, it is already being delivered and this and this. So let's continue on it. I will say like I have not received it. I have not received the items. Where are the items gone? Now it is again checking for order details. It can use previous context, but the thing is it should always be taking in context for latest information. But you can just add few caching there and all of those things. So now it is saying like I'm sorry to hear all of those things, and I understand how frustrated this can be. Then it itself, I have just created a high priority support ticket. Itself created a ticket. It knows when to create the ticket and when not to create the ticket, and all of these things it have given, and it have also told like what to do. So let's end the conversation, and let's say if I ask it, hey, can you help me in booking a movie ticket. Let's see what it comes out to be. As an assistant for this e-commerce store, I only have the tools to help you with your shopping orders, product questions, and all of those things. It cannot book a movie for it. And let's say what is write prime number printing Python code. All right, it does not did it because the system prompt was tight enough. There was enough guardrails to stop it from diverging from e-commerce questions. All right, so with that being said, let's jump in the code. I will, like, this was a demo. I will just try to explain you what's going on. I will also paste the code so that you will get more idea of how things work instead of just telling you the flow. So this is a Next.js application. Like, let me just show you the package.json, which is the thing which you should always in a new project open first. It's using generative AI, which is for Gemini, and Supabase JS, which is for Supabase, and then all of the standard things. And then for Markdown, it's using React Markdown and Remark GFM. All right, there is also README, which like I will add this code to GitHub, then you can read it out. But for now, let's go to layout.tsx. It's a basic root layout. Let's jump directly to page.tsx. There are some UI components and our chat page component. And what it does is it calls API/chat, and when it calls it, like this is a chat input. Whenever we submit a message, this method gets hit, and this just prepares a message to be shown in UI, and it sends the messages to the chat. Like this can be one way to send all the messages that is in current context, or you can just save them in DB and then fetch from DB. Like fetching from DB is much better because right now like anyone can call this API and can send arbitrary messages, which was never done. And then there's some concept of placeholder map and all, which I will tell as we go ahead. Then we are just checking up response, and this API is basically streaming the response via SSE, server side events. so that like you see, whenever whatever tool calls it make, we show it like, hey, it is getting customer information, order information, all of those things. So there is just a while loop, and it's enabling a reader, which is like you can just read about all of these things, SSE and all, how it is done. This video is not for it. Just see, we are getting some events, status and all, whatever we have to show, and then we are getting a final event when we have to stop. Like this will close the stream as soon as messages will drop, and then we will just set the message, show it in UI. So the heart and soul of complete agent is this API/chat, which is a SSE served API. You can also create it a REST and then pull up the details. So what's the agenda? Agenda is from front end, we will get a set of messages. We have to send it to Gemini and ask, hey, what do you think what the user intent is? And then all the loop and all will start. So wait, let me take you to my previous diagram. Right, in my last video, I have told this high level, like I have explained the complete high level diagram of our agent, like general agent. So in our context, whatever we have is like we have a system prompt, we have text input which is given by user. We are not persisting messages in database right now, but we can do it like it's just some CRUD operations. And then these are all the messages of the session, and then memory is also not being created right now because it's an anonymous agent. We can just keep it behind a gate of user ID and all of those things, which is not a part of this video. Everything gets prepared as a context, and that gets sent to the model, which is Gemini. And it has some tool calls. I will show you all of those things. It has some tool calls which call Supabase, get some data or write some data to it. And then it gives some output. And then in the output, we see if the work is done or not. If it is done, we end the loop. Else it goes on loop. It keeps on calling tools, keeps on getting responses. And then once it feels like everything is done, it just gives the response. So up till now, all of the work, all of the heavy lifting is done by this model, which basically decides when to call which tool, and the execution is part of our code. All right, just remember this, LLM does not execute your code. And whenever someone say like agent can execute something, they means LLM will decide, and then we will run the code, and together they will make an agent. Like agent is always model plus harness. Model will never execute your code. All right, so with that being said, let's continue with the code. So what's our requirement? Right now we have front end made up, which takes in a user message, like takes in user messages, and it needs to build a context, and then we need to call the LLM, and then the loop should go on. And then like we are defining our Gemini key, like checking if Gemini key exists or not. Then we are defining Gemini tools, which will eventually go to the Gemini model. These are agent tools, which are like, this is in a schema that Gemini expects it to be. So there are a lot of tool calls, like we have getting customer, getting order details, getting product details, then searching the products, getting the customer information, updating order status, then and create support ticket and checking inventory. So each and every tool will have name, description, and then this is the input schema, whatever. Like we have to define all of these things so that model can give you proper output. Like, hey, just call this get customer orders tool using these properties, using these parameters, which is customer email and then the limit of orders. All right, with that being said, let's head back to where we were. So this is a format which we are later converting to this format, like name, description, and then parameters, which is calling it to Gemini schema, which is converting it into Gemini schema. So right now, this agent tools are kind of generic. You can pass same, I'm not sure about the same syntax, but you can like use all these tools in OpenAI and all of those things. We will cover that part later on, where we just change the model name and it will adapt to it. Alright, then there is a recursive call to Gemini schema, which basically converts it into the Gemini format that Gemini accepts, which is basically this format. And you can just go ahead and just read what it expects, name, description, and these are all the parameters, and all of these things are there. Alright, once all of these things are done, then these are just for this is like writing the image to SSE, and we have a parameter for defining number of max iterations. So if you go to this, like there should always be a exit path where the loop can exit, which can be any of these. So right now we have max iterations, and conditions we are also having, which I will tell you in a while. So right now this condition can help us where, let's say, model hallucinate and it selects a lot of tools and again selects it. So max selection and max tool execution is 5, like max rounds, which we call LLM for, is 5. Then this is a basic endpoint. We are just extracting through data, and then we create a readable string, which is basically server-side event string. This is the method which is used to start the chat. Let's dig into this. All right, we take all the parameters, we initialize the model, we pass in the system prompt and we pass in the tools. Let me show you the system prompt as well. It is a basic prompt. You can extend this to more guardrails and more like, let's say if there are some edge cases, then you can just expand this to more, uh, add few more instructions. But it's better to keep it to the point because models are intelligent enough to figure out what's going on. Our prompt is simple, like you are professional and helpful customer care agent, and you have the power to do all of these things. These are, I will tell you in a while. And then we have tell it when to use the tools and when not to use the tool. All right, with that being said, this is a system prompt. These are all the tools that we passed it. Once we have this initialized, we just call the start chat method, which is again library start chat method, taking in the history. This history is basically all the user messages. Gemini expects the first message to always be a role user. So we basically, if in any case the first message is guidelines which you have to do, and then this is for scrubbing the personal information. We will just start with the user message. All right, then this is basically chat dot send message, which is again like once we get this is like streaming start. Now if I go to definition of this, it says get a new chat session instance which can be used for multi-turn chats. You can just create your own as well, like directly calling Gemini APIs and then handling all of these multi-turns thing. So once we get the result, like it sends the first message to the LLM. LLM gives some results. In that results, it will tell you which tool to call. All right, let me send our first message. Hey, and let's go here. They like user send hey. Then this is the response that we get. Right now, we do not need to call any tool. That's why function calls are 0. And because there are no function calls, we are stopping the loop, which I will tell you in a while, and then just sending this data out. So let me see if we're like show me some products. Right now, I just send it like show me some products. This is the history of our conversation, and it calls like this is the part which I want to show you. Like it gives in response like hey, we need to call this function, and query it right now decides itself because in our system prompt we have not told it to like ask from user. If you want, it can ask user or it cannot ask user. This is the part which we have to update our system prompt for. So it assumes right now that user is looking for a shirt. That's why it just call the query with some shirts. All right, it also asks. So right now in tool call, it expects like it sends a shirt, but then when it goes inside loop, it sees that user have never asked for anything. But once we get this, it gets 0 data, and then it says, okay, what's the purpose of search? Like what do you want to see? And then the loop gets ends because we just had one function call. We call that function, we passed it again to the LLM. LLM decides what to do. It does not give us any function call. It calls stopping loop, and then we send the data. So that's how one life cycle works. So now let me take you back to the code. So this result will carry on the function calls. If there is any function call, this is the part which we are limiting it to. All right, so that we never go above 5 rounds. Once we have function calls, like there can be multiple function calls that it think like, let's say if we ask for an order, we give it the customer ID, then it will fetch the customer and then fetch the orders and then give the list. So there are multiple tool calls can be there. So we need to loop out all of those function calls. We write the event via SSC that hey, this is a status event. We are going to call this tool. And once this thing is done, we just preserve what tool call we made, what was the name of the tool call, and what's the argument. Once we have this, there is a function method known as execute tool, which takes in this tool call, and then it decides, depending on the name of the tool call, it decides which function to call and then return the data of it. Like let's say if it decides that hey, I want customer orders. So this is customer orders method, which basically query our Supabase database. It sees if you have any customer email. If it does not find any customer email, it will say hey, customer email is required. It will return back an error. LLM will read that error, convert that into a decent message, and then show it to the user. Once user reads that, once user provides the email, it will again go on call, like it will again give function calls, and then this method will be called, this time with the customer email. Once we have customer email, we can just query on our Supabase, we query orders. Once we get orders, we return it. Once let's say order gets returned, the control comes to tool result. This is having our orders. We preserve the data, like whatever we have called for like logging and all of those things. And then we have scrubbing personal information, which I will tell you in a while why we are doing this. So let's assume there's nothing here, like data going in, data coming out. We append the response parts. This is again an array, which is having all the responses of functions. Once we have those responses, we again send it to the LLM. Like this was the chat that we opened via model. Once we have this, we send it again. Once we get the results, the thing will continue again. Like if there is any other function calls, like let's say model decides that, hey, I need to call the function again, or I need to call some other functions, this loop will continue max till 5 rounds. And then once there is no function calls, we just return and we just stop the loop. So this is all the agentic loop that's going on right now. It's nothing but just a for loop or a while loop, but there is some guardrails, there's some max output, there's some exit conditions. So let's go again back to our exit conditions. So we have max iterations, we have end conditions whenever there is no function to call. Then if there is any error which we cannot recover from, we just call exit. So right now we are not handling that. We just can add a try catch, and that way we can just handle that case. And then model thinks work is done. This is again if there is no function calls, or if we just need to send the chat response, this condition is met and we break out from the loop. Or else we need some user input, like in our case of customer email. All right. So this was all about loops, and then we just send a final response. And right now we are just using tools. It can use like any external API call, it can use any MCP, or it can use any other thing from which we can get the data. Like let's say web search, it has to do some web seek. All of these things are in our hand. Whatever we give control to LLM, it will tell us what to do. It will not do it for us, it will just tell us what to do. Everyone gives an example of booking a flight. So before agent, how flight booking happens, like let me just tell you it very briefly. So it's very easy to explain with an example of flight booking or something simpler. I'm telling it simplest from the high level. It's easy to understand. If we go drill down into it, there are a lot of things that can go left and right. So let me just explain you, like let's say there's a flight booking. Traditional way, how is this handled? There will be a form which a user will fill the details. Like let's say where, date, which seat, etc, etc. Obviously, once it have all of these things, it shows options for users. User click on book flight CTA, make the payment, get confirmation. So this is the thing which is done in a traditional way like this. What agent will do is it just simply cut down this part, like this part, it will just cut it down. And let's say it will, like agent will ask you where all the same things that the form asks, like where it will also ask your budget and all this, whatever agent is made to do. And then it will show options to users. And then the thing continues. If the agent does not handle payments, there are some agent which can handle payments. For it needs to get authorization. Hey, I'm declaring this agent can spend around $1,000 from my card. If it have that power, then it can make the payment and user will just get this part, like get confirmation directly. So it cut down the effort of finding the flight, thinking on budget. So always think agent or any other system from how a user will do it. We are just cutting the time of user, which user will spend on thinking, comparing, all of those things. That's it. There is no other motive of an agent than to cut users time. All right, let's get back to where we were. So all right, one thing which remains is scrubbing the PII, which I intentionally added it, but I thought like why not to explain you some production concepts as well. So wait, let me see where it was. All right. Once model decide that, hey, call this tool, like let's say model decide call customer tools. Once it call the customer tool, it will get all the data of customer, which includes email, their phone number, all of the other things, order details, address, payment method, all of those things should never go to LLM, because privacy should be taken seriously. You never know whenever a company decides to use the data for training purpose, and once that happens, your customer data will be with the model company, let's say Gemini, let's say Google, and they can use it in any way they want. That's why we never pass our, like it's similar to passing our environment variable files to Cloud Code. We never do it because we know the risk of the environment variables getting stolen or being released to the public. That's why privacy should be taken very seriously. This method, what this does is, right now it's a basic token substitution, which basically looks for all of these keys. If it finds these keys, it will just scrub it and will make it something like, let's say this email, johndoe@gmail.com. So what will this scrubbing will do is, it will just create this and just to do this. So this will be passed to LLM. LLM in response will give this back, because in our system prompt we have said it very clearly. But let me show you the system prompt. This part, handling placeholder tokens. Some fields in tool results are personally identify information, like all of these things are replaced with tokens like email, first name. In the response, treat this token as if they were real value and copy them into your response. So whenever LLM gives you a response, like argument or whatever it gives, it will gives you in this format. Like let's say if we want to ask email from user, or we have an email of user, it will in response give this token, and then we will just decode it back. Like we will just use our information which we have placed in the placeholder map that we had, this one, and then construct that information to pass in the response and show it inside. So right, then there are a few method of it, like just replace every key with text, all of those things, pretty basic stuff. All right, I guess this should be sufficient. Next video we will cover more into how we can like add few more tools, maybe MCP or something, or evaluations of models. There are a lot of things which can go wrong in the simple customer care agent as well. Let's say if it hallucinates, let's say generate some data which was never asked, it assumes something, like there can be a lot of things that can go wrong. All of these things, like all the production agent which I have built, I have always keep in mind the evaluation first, how we can evaluate the process that LLM follows, so that the risk of hallucinating or risk of getting it wrong reduces. Like you cannot say 100% your agent will behave the way you are explaining it to do or you're expecting it to do. There are hiccups. You see the production data, you see production logs. If there is any hiccup, you might either update the system prompt, update the tool calls, or add some more guardrails and just improve your harness altogether. And the second time, let's say I want to update my prompt. If I do not have evals, there are things that can go wrong which was working fine previously. So that's why evals, test cases, all of those things matter a lot in the agentic systems. We will cover that in some later part. So I guess it should be enough. I hope you like the video. If you like it, just hit the like button. Also subscribe to my channel. I will keep on adding one video a day for agents, so that agentic systems that looks very scary from outside becomes easier to build. So that's it.